Just after midnight, July 1st, 2012, the check-in systems at Qantas Airlines go dark. Staff grab pens and paper while flights across Australia stack up. And at the same moment, on the other side of the planet, Reddit crashes, LinkedIn crashes, Mozilla crashes. Nobody was hacked and nothing was unplugged. All of it, the airline, the websites, the chaos, came down to 1 extra second. That night, the world's timekeepers had inserted a leap second, a 61st second tucked quietly into the last minute of June. Suddenly, millions of computers hit a moment in time they didn't believe existed. 23, 59, 60. Some of them simply gave up. This is the story of one of the most important numbers on Earth, the exact time, where it really comes from, and why the modern economy quietly depends on it being right to a millionth of a second, and why in 2035 the world will change how time itself really works. Here's the first surprise. There is no master clock, not one anyway. No single device on Earth holds the official time. Instead, around 420 atomic clocks in more than 80 national laboratories each tick away on their own. The official world time, Coordinated Universal Time, or UTC, is a weighted average of all of them, computed by a small office near Paris called the International Bureau of Weights and Measures. Think of it as a democracy of clocks. The steadiest clocks earn bigger votes in the average, and that is exactly the point. No fire, no earthquake, power cut, nothing anywhere on Earth can take down time itself. And now the strangest part. The average is computed after the fact. The Bureau collects the clock data, runs the math, and publishes official time in a monthly bulletin called Circular T. Think about what that means. The world's official time is only truly known weeks later. Every clock you have ever read was making an excellent real-time prediction of a number that had not been calculated yet. So, what makes a clock atomic? Inside, Cesium atoms are struck with microwaves, and they respond only at one exact frequency. The same frequency for every cesium atom in the universe. Since 1967, the second itself has been defined this way: 9,192,631,770 oscillations of a cesium atom. That's it. The second is no longer based on the Earth or the Sun, it is based on the atom, and it has not changed since. 9.2 billion beats. That is the heartbeat of civilization. Every single second you have lived since 1967, exactly this many vibrations of an atom. To see why we trust atoms with the time, look at how far clocks have come. A medieval mechanical clock drifted a full second every couple of minutes. The pendulum stretched that to hours, and by the 1920s, the finest pendulum clocks on Earth lost about 1 second per year. Then came quartz. Then in 1955, the atomic clock. Today's best cesium fountains won't gain or lose a second for 300 million years. And the optical clocks now in testing, they would stay true longer than the universe has existed. And here's the thing. This is not the first time civilization has bet a fortune on a better clock. In 1707, 4 British warships run onto the rocks off the Isles of Scilly in fog. More than 1,500 sailors drown. The fleet was lost because nobody on board knew where they were. Out at sea, longitude is really a clock problem. The Earth turns 15 degrees every hour. So if you know the exact time back home and you compare it to local noon, you know how far around the planet you've sailed. The catch? No clock could survive a rolling, damp, freezing ship. So, in 1714, the British Parliament put up £20,000, millions in today's money, for anyone who could solve longitude. A carpenter's son named John Harrison spent the next 4 decades building clocks accurate enough to do it. His final design, a large pocket watch, just lost seconds crossing the Atlantic. He still had to fight the scientific establishment for most of his life to collect the money, but the point was made. A nation's wealth could hang on a clock, and it still does. Now, why would anyone need a clock more accurate than that today? Well, many of us don't. Your entire life happens comfortably at 1 second precision. But the machines that run your life? Different story. Communications, navigations, finance, and electricity. The systems underneath modern civilization need the world's computers to agree on the time, to within millionths and sometimes billionths of a second. Take the stock market, for example. Modern exchanges match millions of orders per second, and who came first can be worth real money. So in Europe, it is literally the law. Under the regulations known as MiFID II, high-frequency trading firms must keep their clocks within 100 microseconds of official time, and they must stamp every single trade to the microsecond. When regulators reconstruct a market crash, they are reading a diary written in millionths of a second. And the trading world has quietly rerun the longitude prize. Firms built private microwave relay towers between Chicago and New Jersey, because microwaves through air beat light through fiber by about 2 milliseconds. And 2 milliseconds in this world is an eternity. Some firms go even further. They install their own atomic clocks right in the data center, so that even if GPS hiccups, their timestamps hold. 300 years after Harrison, serious money still buys better clocks. Or take GPS, for example. We call it a navigation system. It's really a constellation of flying atomic clocks. Your phone finds itself by comparing tiny differences in when each satellite signal arrives. Light travels about 30 centimeters in 1 nanosecond. 30 centimeters. So a clock error of just a few billionths of a second puts you in the wrong lane or on the wrong street. A study commissioned by the US government put numbers on that dependence. GPS has generated about $1.4 trillion of economic value since the 80s. And losing it? As much as $1 billion a day. During planting season, when GPS-guided farm equipment sits idle, it could be far more. And it's not just your location on a navigation app. Cell towers use GPS timing to share the airwaves without talking over each other. Power grids time-stamped sensors across thousands of kilometers to spot failures as they ripple through at near the speed of light. The clock is infrastructure, as real as roads and pipes, and far easier to forget. Your phone, meanwhile, gets its time through a quiet chain of hand-me-downs. National labs feed time servers, and those time servers feed the internet's time protocols, and those feed your devices. Billions of requests a day, syncing the entire internet back to those atomic clocks. So when your lock screen says 9:41, it agrees with a laboratory in Colorado to within a few hundredths of a second. Which raises an uncomfortable question. What happens if someone lies to the clocks? GPS signals arrive from space extremely weak. They're easy to drown out, easy to fake, and in 2017, ships in the Black Sea started reporting positions miles inland, parked at an airport. Experts read it as deliberate spoofing. Airline crews near conflict zones now log GPS interference daily. And a spoofed clock is not just a wrong map pin. Shift a bank's timestamps and you can reorder the transaction history itself. So governments are quietly building backups, ground-based radio time and hardened receivers, and timing fiber that never touches the sky. This all brings us back to that 1 extra second at the beginning of the video. Here's the problem. The Earth itself is a terrible clock. Its spin wobbles and slows irregularly, so atomic time and Earth time slowly drift apart. Since 1972, whenever the gap approached a second, the timekeepers inserted a leap second to let the planet catch up. They've done it 27 times. And every single insertion forces computers to survive a minute with 61 seconds, a timestamp many systems were never designed to represent. In 2012, a bug in the Linux operating system made servers lock up the instant the extra second arrived. That's what took down Reddit and left airline staff checking in passengers by hand. Later leap seconds caused glitches too, which is why companies like Google now cheat. They smear the extra second invisibly across the whole day. So, in November 2022, at the Palace of Versailles, the world's timekeepers voted to give up. From 2035 at the latest, leap seconds will stop, and atomic time will simply drift away from the natural time of the Earth and Sun for at least a century, while a better fix is worked out. But there's one final twist. Since 2020, the Earth's rotation has been speeding up. Nobody knows fully why. Recent years have logged the shortest days ever measured. If the trend holds, then before the leap second is abolished, we may need the first negative leap second in history, a minute with only 59 seconds. Not one system on Earth has ever been tested against a minute like that. And the engineers who survived 2012, they're already dreading it. So, the next time your phone shows the time, remember what's underneath it. 420 atomic clocks and a small office near Paris, a monthly bulletin and an army of engineers making sure the most important number on Earth never skips a beat. If this changed how you see your clock, subscribe. There's a lot more infrastructure hiding in plain sight.